A 10 kilogram watermelon and a 7 kilogram pumpkin are attached to each other via a cord that wraps over a pulley. Friction is negligible everywhere in this system. Find the acceleration of the pumpkin and watermelon. Specify the magnitude and direction. If the system is released from rest, how far along the incline will the pumpkin travel in 3 seconds? And what is the speed of the watermelon after 0.2 seconds? That's the diagram, what's going on. The forces acting are on both the pumpkin and the watermelon are gravity, tension, and the normal force, and there's the free body diagram for that. So the formula that I use to figure this out is tension equals mass times gravity plus mass times acceleration. And since they're both connected to the same cord and they're both pulling on each other, the tension is going to be equal for both the pumpkin, and the tension of the cord is going to be equal on both the pumpkin and the watermelon. So I can figure out the mass times gravity plus the mass times acceleration for both of them, and set them equal to each other. So right there it says the tension of the watermelon equals tension of the pumpkin. So I set everything equal to each other, and after I did that, I was able to isolate acceleration on one side of the equation, and I solved for acceleration and found out that the acceleration on the watermelon will be 0.34 meters per second squared, and it'll be in the positive direction and to the left, and so it'll be up and to the left, and the pumpkin is going to have a negative acceleration of 0.34. And the next part of the problem was to figure out how far the pumpkin would travel in 3 seconds if the system was released from rest. So I plugged in my acceleration to this formula. Change distance is equal to half acceleration times time squared, and I ended up with 1.53 centimeters. And the last part of the problem was to figure out the speed of the watermelon after 2 seconds. So I used the equation velocity is equal to acceleration times time, plugged everything in, and got a position of, or a distance of, I got a velocity of 0.068 meters per second, and I converted that to 6.8 centimeters per second.